Hello and welcome to Technical Utkranti, and today we are going to see how to find minimum number of platforms for given trains. So for given trains I means given arrival time and departure time of trains. So this is the second question under the greedy algorithm section, and this is the thought for the day. All right. So this is the question. You are given the arrival time, as you can see here, of three trains and the departure time of three trains. So how are we going to identify the minimum number of platforms required for such a timetable? Let's have a look. So these are arrival and departure times. So first thing we are going to do is to sort them. Why do we need to sort it? So with sorting we get the next lowest time that could be managed or that could be handled. So we have this sorted times. Now what we'll do is we'll compare the first departure with the second arrival to begin with, right? Now I see that the second arrival is happening before the first departure. So what I will do is I'll introduce another platform here. So P1 for train 1 arrives at P1, then train 2 arrives at P2. It is looking little bad. So train 2 arrives at P2, right? Now, the next, so once we increase our platform count, we move the arrival pointer to the next pointer here, next value. So arrival time is this. Now I see that arrival time is greater than the departure time. In that case, we do not need to increase the number of platform. So what will happen is train 1 will depart from platform 1. Now platform 1 gets empty. So train 3 arrives at platform 1. And when the same platform is used, the departure time moves ahead, and so does the arrival time. And as soon as the one of the pointer goes outside, we are done. 12 and 15 are the arrival and departure of one train. So this train has already arrived at platform 1, so this can depart from platform 1, right? And then this is the train 2 which has already arrived at platform 2, so this can depart from platform 2. Makes sense, right? So 5 and 10 are the arrival and departure times of the first train. Then 7 and 16 were the arrival time of this train, let it be T2. So we see that T2 arrives at P2 and then leaves at P2. And then T3 arrives at P1 because by this time P1 is empty and leaves at P1. So algorithm you understood, right? It is that if AT is greater than TT, or if AT is less than DT, then we increase the platform by 1. Otherwise, if AT is greater than DT, then we don't need to increase the platform. We use the earlier emptied platform, and both arrival time or arrival pointer increases by 1 and departure pointer increases by 1. And Yeah, and over here, just the arrival pointer increases by 1, right? And as soon as the 80, so this will go on while 80 is less than n and dt is less than n. And to begin with, dt is 0 and 80 is 1. So I hope you understood the algorithm. Let's look at the code. So this is the code. As you can see, I have sorted the arrival and departure times to begin with. Arrival pointer is 1, departure pointer is 0. So this is the initialization. So if there is at least one arrival, then there will be one platform. Otherwise, there will be no platform. So while arrival pointer and departure pointer are less than number of trains, then as you can see, if the subsequent arrival is less than the current departure, then we increase the platforms and increment the arrival pointer. Otherwise, we increment both arrival and departure and then return the number of platforms at the end. So this should run fine. Yes. So I hope you like the question, the approach, and the solution. So if you did like, please give it a like and a thumbs up and subscribe to my channel. Thank you. Bye bye.